Good morning. Today we are going to be continuing with probability and also actually doing more theoretical probability. So that's what we were talking about yesterday. We will continue to practice with that today. There's a lesson note again. There will be for this entire unit. So if you'd like, you can print that out to follow along. So if you remember from yesterday, and hopefully we do, the theoretical probability formula is the probability of an event happening is equal to the number of successful outcomes divided by the total number of possible outcomes. Okay, so we're going to continue to use that today as we go through some examples. So to calculate the theoretical probability, all outcomes must be equally likely. Whoa, and that is important, okay, that they are equally likely. So what does that mean, though? It means that each event has the same chance of occurring because the conditions are fair. There's two R's in the word occurring, did you know? Okay, so that's like the two we talked about yesterday, right? Flipping a coin, pulling a card from a deck, rolling a die, all of those things, the options are equally likely. You have the same chance of getting all of the possible outcomes. All right, so we talked yesterday a little bit about tree diagrams. Okay, so tree diagrams are one way of representing possible probability outcomes. So let's draw a quick tree diagram for tossing a coin twice. Okay, so on the first toss, toss number 1, your options are either heads or tails, right? And then we have the second toss. If you got a head, your options are heads or tails still. And then same if you flipped a tail, you could have the same options there. So our different possibilities . There are 4 of them, right? You get head, head. You could get head, tail. You could get tail, head, or tail, tail. Okay, so there are 4 possibilities with this situation, right? So when you're flipping 2 coins, right, there are 4 different possible outcomes. So another way that we can represent these things is in a table. Okay, so you can do a tree diagram or a table. So, excuse me, in this first example, we have Mark, Jenny, and Otto each having won a t-shirt from West 49. Perhaps this is a little dated. At a store grand opening event. Each shirt is randomly assigned to the 3 winners. 1 is red, 1 is black, 1 is green. What is the probability that Mark will receive a black t-shirt? So I filled in this chart already. Okay. R, B, and G to represent the colors of the t-shirt. Right, so Mark could get a black shirt. Jenny could get green. Otto could get red. Mark could get black. And then the red and green could be switched, right? So I just kind of filled this in with the black being the block and then switching the other 2 colors. Okay? So in how many different ways can the shirts be distributed? There are 6 different ways, right? 1, 2, 3, 4, 5, 6. And in how many of these arrangements does Mark receive the black t-shirt? 2 of them, right? So there's 1 and 2. and then he doesn't receive the black shirt any other time. So what's the probability that he will receive the shirt? So the probability of the black shirt is, you do the number of successful outcomes, so that is 2 successful outcomes, over the total number of possible outcomes, which is 6. And we reduce our fractions to lowest terms, okay, or we could say 33%. Okay, so that's our first example. I've got 2 more. This next one is, we're talking about dice, okay, so the probability, of rolling doubles with a pair of dice. So along the top of this table, I've got the number on the first die, 1 to 6, and then the number on the second die, 1 to 6 as well. And I've circled all the time you get doubles, right? When 2 1s happen, 2 2s, 3s, 4s, 5s, and 6s. Okay? So, in how many ways can 2 dice be rolled? How many possible outcomes are there? So, in this, we count all the number of boxes in here, and there are 36. How many ways can doubles be rolled? Well, I've circled them. There are 6 ways that doubles could be rolled. Okay, so the probability of doubles is equal to, how many successful outcomes are there? 6 over 36 total. We can reduce that to 1 over 6, or write it as a percentage, 17%. Okay? Last example. Now we're looking at the sum of the 2 dice, so when you add them together, okay, so the table looks the same around the outside, 1 to 6 and 1 to 6, and then you add up the numbers on the die to get the inside here. Okay, so again, there are 36 possible outcomes. In how many ways can the sum of 7 on the 2 dice be rolled? So 7 is the most common because there are many ways to get to 7 with these numbers, right? 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1. Okay, so there are most ways to find 7. So there are 6 ways to do that. What is the probability of rolling 7s with a pair of dice? So probability of 7s is equal to the total number of times you could possibly get 7, which was 6, over the total number of sums of 36. This is the same as before, actually, right? So 1 over 6, or 17%. Okay? The last question here, we got to think a little harder. It's the probability of rolling odds. So our odd numbers in here are 3. 3 is an odd number, right? 5, 7, 9, and 11. Okay, so those are odd numbers that are included in this chart. So now we just count up. So the probability of odds is equal to, we count them up. So 1, 2, 3, 4, 5, 6, plus 6 is 12. 13, 14, 15, 16, 17, 18. So there are 18 possible odd numbers to get when you roll your 2 die over 36 total possibilities. So we reduce that fraction to 1/2 or 50%. All right, that's it for today, guys. Try the practice problems and let me know how they go.